Hello everyone. Today we are going to start chapter 2 of Science Class 10th, that is Acid, Bases, and Salts. So, this chapter revolves around us, our daily activities, and uh, what should I say? So, it is about our overall life. So, we do see acids, bases, and salts in our daily lives, in our body, in our laboratories, in our surroundings, in kitchen, as well as everywhere. Okay, so we are going to discuss about these in brief. So before getting started, these are two terms. First is litmus and second is pH. So let's just quickly understand what are these. So litmus is basically a purple dye which is extracted from lichens. Lichens are basically plants which do belong to Helophyta kingdom. Okay, so these are the plants that do belong to Helophyta kingdom. So these are basically purple in color. Litmus is a dye which is purple in color. So it changes color when it comes in contact with any acid or base or other substance, right? So basically it is purple in color, right? Then the next term is pH. So pH stands for power of hydronium ion concentration or hydrogen ion concentration. It basically measures if a solution is acidic or basic and how much acidic or how much basic a solution is. Okay, so the acidity or basicity of a particular solution depends on the concentration of hydrogen ions. If the concentration of hydrogen ions in a particular solution is high, right? If high concentration of hydrogen ions is present in that particular solution, then that particular solution would be regarded as acidic solution, right? And if the concentration of hydrogen ion is low, then the solution would be regarded as basic. Okay. So this is the first characteristic over which we describe or discriminate or differentiate between acids and bases. The property is hydrogen ion concentration. High hydrogen ion concentration means acidic behavior and low hydrogen ion concentration means basic behavior. Or more the hydrogen ion concentration, more the solution would be acidic. If the concentration is less, then the solution would be less acidic or more basic, right? Okay. So, what are acids? Acids are basically the compounds that have high concentration of hydrogen ion concentration, right? High concentration of hydrogen ion means the solution is acidic. Acidic solutions are sour in taste. And one property about them is if the blue litmus is dipped into those solution, then it would turn the blue litmus into red. Okay. And the pH of acidic solutions is less than 7. So when we are measuring pH of a particular solution, so we do measure pH on the scale of 1 to 14. Okay. If the solution ka pH is less than 7, so less than 7 would be regarded as acidic and more than 7 would be regarded as basic, right? So 7 is the baseline and if the solution is having pH 7, that would be regarded as neutral. So if a solution have pH less than 7, then the solution would be regarded as acidic. If the pH is greater than 7, the solution would be regarded as basic. And if the solution is having pH equal to 7, the solution would be regarded as neutral. It is neither acidic nor basic, right? So some of the examples of acids are hydrochloric acid, HCl. HCl we discussed in our fifth chapter, right? That HCl is also present in our gut. So acids are also present in our body, outside our body, within the laboratories, or within the food we consume in the form of citric acid. Citric acid is present in lemons, oranges, and all the other citric fruits, right? H2SO4, sulfuric acid, we do uh, perform experiments in laboratories using H2SO4. Okay. Then acetic acid also present. Then, so here are the few acids that are of natural sources, right? So which are naturally present apart from their chemical production, or sorry, um, laboratory production or in the manufacturing in factories. So there are a few natural sources of these acids as well. So acetic acid is found in vinegar solution, right? Citric acid is found in oranges and lemons as well. Lemons also contain citric acid. Then tamarind contains tartaric acid. Tomato contains oxalic acid. Curd contain lactic acid, which is made up of lactobacillus. Like the milk is getting converted into curd because of the lactobacillus bacteria, so it produces lactic acid. Okay, so if her aunt is biting our skin, okay, so the sting of that particular ant which is dipping into our skin, so that particular sting of the ant or bee or any other insect contains methanoic acid, right? So then again, nettle sting contains methanoic acid, right? So these are some of the naturally occurring acids which are present in our surroundings, in our food, within our body, etc. Okay. So these are naturally occurring acids. So here's a question for you, that why does an acid not show acidic behavior in the absence of water? So there comes a property of acids, like I already mentioned, the acidic property of a particular compound is due to the presence of hydrogen ion concentration. Okay, so hydrogen is present in its ionic form, and ionic form is due to the presence of water. So any particular compound is breaking down or oxidizing into its ionic form, getting oxidized because and dissociate into its ionic form because of water. So if water is not present, then we would say that the acidic behavior is not showing. There is acidic behavior, but it is not getting showed, right? So because of the presence of water, it basically ionizes into its ionic form and dissociates into its ionic form, and that's why its behavior is only shown when the water is present. Then coming to our next topic, that is bases. So what are bases? So bases are basically the substances that can accept hydrogen ions. So acidic compounds do contain hydrogen ions, and then they can donate those particular hydrogen ions. But bases are the substances that can accept hydrogen ions, and they can donate a pair of valence electrons. There is one more thing, that not all bases are soluble in water, right? Remember this thing. Not all bases are soluble in water. And okay, we'll discuss this particular term in our next slide. Okay. So then the taste of bases is basically bitter. Okay. So acids were tasting sour, whereas bases are tasting bitter. And the bases are also soapy in touch. When we touch the bases, they do feel like soap. Okay. Also, another property about bases is that they turn red litmus into blue. When we dip our red colored litmus paper into the bases, the color is changed into blue. It is just opposite to what was happening with our with acids. Okay, so acids were changing the color of blue litmus into red, whereas bases are changing the color of red litmus into blue. Okay, then another property I already mentioned, that these are the compounds, elements, or solutions that do have pH greater than 7, right? Some of the examples contain NaOH, sodium hydroxide, KOH, potassium hydroxide, ammonium hydroxide. Okay, then again, so here is the term I already mentioned in the previous slide that not all bases are soluble in water. So a base that is soluble in water or releases OH ion in solution is regarded as an alkali. Okay, so uh, all alkalis are bases. Okay, so we can categorize all alkalis as bases, but not all bases are alkalis. Like in the previous slide, I already mentioned that not all bases are soluble in water. So those bases which are soluble in water are regarded as alkalis. Okay, and those that are not soluble in water or that do not dissolve in water are regarded as bases only. So the bases that are soluble in water are regarded as alkalis. Okay. So the base that is soluble in water and release OH minus OH minus or uh, OH minus ions in water or in any solution are regarded as alkalis, and rest are not alkalis but they are just bases. For example, sodium hydroxide and potassium hydroxide. So when we will mix NaOH with water or any other solution, it would give OH minus and further H2O would be formed Na plus plus OH minus. It would dissociate into Na plus and OH minus. Right? Right. Okay. So here is again a question for you that if you have been provided with three test tubes, you have three test tubes, right? One test tube, one, two, and three. Okay, so this is test tube one, this is test tube two, this is test tube three. All are filled with a particular solution. Okay, suppose this is A, this is B, and this is C. Okay, okay. Now, the condition is that one of them contains distilled water and the other two contains an acidic solution and a basic solution. Okay, but we don't know that which particular solution is filled in which test tube, right? We know that we have three test tubes and one contains distilled water, one contains an acidic solution, and one contains an basic solution, right? But we don't know that which particular test tube contains which solution, right? Okay, so if you are given only red litmus paper, okay, if we have only red litmus paper, now how will you identify the contents of each test tube? We already know that the red litmus turns into blue if it is dipped into a base, right? So we can easily identify a particular solution as a base. So we have identified that a particular solution is base by dipping the litmus paper. So we'll dip the litmus paper into all three test tubes and the particular solution which would turn the color of red litmus paper into blue would be regarded as base. So suppose we have dipped a particular solution, the litmus paper into A, then there was no reaction. In B, there was also no reaction, but in C, the color of red litmus turned into blue. So we can identify that the C test tube was a base, right? Okay. Now here the matter is sorted. Okay. Now the question arises that how would we identify with the help of a litmus paper only between if a solution is acidic or distilled water only. Okay. So in distilled water there would be no reaction. Also in acidic solution with the red litmus paper there would be no change. Okay. Then what would we do? In that particular condition, we can try mixing these two solutions into the already identified one. So what happens is when we add distilled water to a base, then there would be no reaction. Also, when we would add distilled water into acid, there would again be no reaction. Okay, but if we add a acidic solution to a basic solution, then there would be a popping sound, or I must say there would be a spark or some sound. Uh, we'll call it sansanahat, right? So there would be sensation, some sensation, right? Okay, so there would be some sensation because of the mixing of acid and base. So we'll try mixing A solution with C. So there would be no reaction. Suppose we added A and C and found no reaction. So we can consider that A is distilled water and nothing else. Okay. And we added B with C again. We have added V into a basic solution and there was some sensation. So we can consider that the B solution or the B test tube was an acid, C was already identified as base, and A would be regarded as distilled water. Okay. Okay, so now let's move further. Okay, so then the term comes indicators. What are indicators? So we have already discussed about litmus paper. That litmus paper can be used as an indicator to identify if a solution is acidic or basic by dipping the particular litmus paper into the solution, right? Okay. So indicators are basically the substances that change the color. Indicator, how can we identify something is the indicator? If it is changing color, right? So if it is changing color, so we can identify or we can recognize that a particular solution have some properties that are leading to the change in that particular change, right? So the change is because of some properties, right? And something that is changing color, that is also a property. So indicators are the substances that change color in acidic or basic solution. And okay, these are the substances that changes color in acidic or basic solutions, right? First of the example of indicators can be litmus. So in basic solutions, the color of red litmus changes into blue, and in acidic solution, the color of blue litmus changes into red. Okay, this was about litmus paper. Then there is another indicator that is regarded as phenolphthalein. Phenolphthalein is another indicator which is colorless in acidic, so it does not change any color in acid, but it changes into blue. Oh, sorry, it changes into pink when it is dipped in bases, right? So when we add few drops of phenolphthalein indicator in our basic solution, it would change color into pink, right? But there would be no change in colorless solution. There would be no change in case of acidic solution, right? Then again we have another indicator which is methyl orange. So it changes into red when it is added into acidic solution. When we add a few drops of methyl orange solution or methyl orange indicator into acid, then its color would change into red. Whereas it would convert into yellow when it is added in a base. So phenolphthalein, it would be colorless in acid and pink color in base. Methyl orange, red color in acids and yellow color in bases, right? Other than these, there are a few natural substances as well, like red cabbage, turmeric, colored petals of some flowers, which also act as indicators, right? These also do act as indicators. How do turmeric act as indicators? So when we suppose we were having some food and we by mistake we dropped it on our clothes, right? So while washing it with a soap, its color, its yellow color, the yellow color of turmeric would change into red. It would suddenly change into red when it will come in contact with a base. Okay, so hence turmeric also act as an indicator. Okay, so now let's talk about some acidic and basic reactions. Yeah, reactions between acids and bases. I already mentioned that when we add acid into a base or a base into a acid, there would be some sensation, right? So, acid and base reactions are regarded as neutralization reactions. So, the reaction between an acid and a base to give salt and water is regarded as neutralization reaction. So, when a acid would react with a base, what would we get? We get a salt and water. For example, HCl, hydrochloric acid, is an acid, then it reacts with NaOH, which is a base. So we get NaCl, which is salt, right? Plus H2O. Okay. So this is how we get salts. Okay. So there is one more thing that we need to discuss. Okay. So upon the reaction of acids and bases, we are getting salts. Okay. So suppose we are reacting a strong acid and a strong base. So we are getting what? Salt plus water. Suppose we are adding a weak acid and a strong base. What would we get? So upon the reaction of weak acid and strong base, we would get strong basic oxide, or we say, okay, we'll discuss it in further slides so that you could get more clarity. Okay, so there is one more thing that we were discussing the reactions of acids and bases. Now we'll discuss about the reactions of acids with metal. So when the metal in the reaction displaces hydrogen atoms from the acid as hydrogen gas and forms a compound called salt, then there would be, so this basically happens in the reaction of an acid and metal. So when a acid and metal reacts, there would be the formation of salt and hydrogen gas. So when a acid was getting reacted with a base, salt was forming and water was forming. But when acid reacts with a metal, okay, so acid is reacting with a metal, then salt plus hydrogen gas are formed. For example, Zn. Zn is zinc plus H2SO4 gives ZnSO4 plus H2. Okay, how would we get to know that the hydrogen gas is evolving in the reaction? So we have just mentioned that the hydrogen gas is evolving, but how would we get to know that the hydrogen gas is evolving? Because we can't see that. So there is a test to bring that evolving of hydrogen into notice. The basic property of hydrogen gas is that it is flammable in nature, right? So hydrogen is flammable in nature. Okay. So when we will bring a matchstick or burning matchstick near the test tube in which this particular reaction is taking place, suppose there was a zinc nail. Okay, we have taken a zinc nail in a test tube. Okay, now we are pouring H2SO4 into it. So ZnSO4 would be formed, which would be a salt. The solution would contain a salt plus hydrogen gas is evolving. How would we identify the evolution of that particular hydrogen gas from the test tube? We'll bring a burning matchstick near the test tube, and there would be a sound of pop. Okay, there would be a pop sound because hydrogen gas is flammable, and when we are bringing the burning matchstick near to that particular test tube where hydrogen gas is evolving, there would be a spark. Okay, so there would be a spark for very short duration, right? So where there would be a very short or minute spark or a pop sound that signifies the presence or evolution of hydrogen gas from the test tube, right? So this was about the reaction with metals. So when an acid reacts with a metal, a salt and hydrogen gases evolve. A salt is formed and hydrogen gases evolve. Another thing that comes here is the reaction with carbonates. Okay, carbonates are what? CO3, CO2, etc. Okay, so limestone, chalk, basic the chalk, calcium carbonate it is, and marble are different forms of calcium carbonate. So we are we are checking the reactions of acids with carbonates. Chalk is what? CaCO3, calcium carbonate. Okay, so when a chalk, oh sorry, when a acid would react with carbonate, what would happen? So there would be the formation of a salt plus CO2 would be evolved and water. Okay. So while the acids were reacting to metals, there was evolution of hydrogen gas only and formation of a salt. But when the acids react with carbonates, then a salt is formed, carbon dioxide is released, and water is released. Okay. How would we get to know that the carbon dioxide is getting evolved? Okay, so there is a reaction in which Na2CO3 sodium carbonate is reacting with HCl. HCl is acid, right? So sodium carbonate is reacting with HCl, which is resulting in the formation of NaCl, which is a salt, and CO2 and H2O. So there is again a test to confirm the evolution of CO2. That is that if we would like CO2 turns the lime water into milky, right? So this is the test. So when in that particular watery solution, because of the lime is what? Lime is CaOH, right? So when we would add the lime into that particular solution, okay, so because of the presence of CO2, it would convert into CaCO3. Okay, so this formation of CaCO3 would result in the line CaCO3 would be formed as a precipitate. In the previous chapter, we also discussed the precipitate. So it is a whitish powder-like structure which is not dissolved or settled on the bottom of the test tube. So, okay, so CaCO3 is formed and CaCO3 appears white in color because it is a precipitate. Okay, so it appears whitish in color and gives the water milk-like appearance. So CO2 turns lime water milky. Okay, so it is not converting the particular solution into milk. It is not producing milk, but it appears like milk. Okay, because it is white in color, milk is also white, so it appears like milk. Okay. Okay, then the reaction of metal oxides. So metal oxides are basically basic in nature because oxides are what? Oxides would contain OH minus ions. Bases also contain OH minus ions. So in that particular reaction, we are reacting the acid with a base. So the reaction would be similar to the neutralization reaction. So metal oxide plus acid would result in the formation of salt and water. So, for example, calcium oxide, CuO, sorry, copper oxide, CuO plus HCl gives CuCl2, which is a salt, and water, right? Okay. Then moving to our next slide about uses of acids and bases. So, where do we use these acids and bases? So, acids are used in batteries as battery acids. Food preservation. How do we use acids into food preservation? In the form of vinegar. Vinegar may we know that vinegar do contain acetic acid. Okay. We know vinegar contains acetic acid, so it is further used in food preservation, so it is the use of an acid. Then further manufacturing of different items in industries at large scale. Okay, now coming to our next compound, that is base. Bases के use क्या होंगे? Bases are used in making of soaps, cleaning agents, antacids, etc. Okay. Then next term is pH scale. So what is a pH scale? I already mentioned that we measure pH on the scale of 1 to 14, right? If the pH of a particular solution is less than 7, it would be regarded as the acidic solution. The pH of the particular solution is greater than 7, the solution would be regarded as basic solution. So if the pH is less than 7, solution is acidic. pH is greater than 7, solution is basic. And at 7, pH is neutral. Simple. Okay. So pH is used as an indicator to identify or indicate or assess how much a solution is acidic or how much the solution is basic. So lesser would be the pH, more would be the acidic character, or greater would be the pH, more would be the basic character. So as we move down from 7, acidic character increases. So a solution having pH 1 would be more acidic than a solution which has pH 6. Okay, so pH 6 solution would be a weak acid, whereas pH 1 or 2 solution would be a strong acid. Similar with bases, that if a solution having pH 8 is weaker than a solution which have pH 14. Okay, so pH 8 solution would be a weak base, whereas a solution having pH 14 would be a stronger base. Okay, another thing is that universal indicators show range of pH by colors. So we can identify, there are some universal indicators or universal indicators in the form of pH papers as well. So they do change color. They do indicate the pH of a particular solution on the basis of the color it acquires after getting dipped into that particular solution. So this is a pH scale, and इसके basis पे we can identify what would be the pH of a particular solution. If it is dark red in color, then the pH would be 0, then orange, yellowish, then yellow, green, dark green, blue, purple. So the color changes. So on the by seeing the pH scale, we can get idea about what would be the pH of that particular solution. So there are some gastric juices which are present in our gut or stomach, which is let's HCl. HCl is present in our stomach, right? So it has pH 1 or 1.2. Lemon juice contains citric acid, and citric acid do have pH 2.2. Again, pure water, if the pure water or the blood is present, so it would have pH 7.4. Simply on the neutral side, right? If, okay, so there would be a concept of acid rain as well. Okay, so acid rain. So the pH of normal rain is around 5.6. Okay, न्यूट्रल टू स्लाइटली एसिडिक होता है नॉर्मल रेन का पीएच. बट इफ इट इज लेसर देन 5.6, if the pH of acid rain is if the pH of rain is less than 5.6, then that particular type of rain would be regarded as acid rain. Okay. Okay. Then again, milk of magnesia do have pH 10. Okay. And now 14 pH किसका होगा? NaOH, which is a strong base. NaOH, sodium hydroxide. Is it clear? Okay. Now let's move ahead about the importance of pH. What is the importance of pH? क्या importance है pH की? Why are we studying about pH? So, the pH of human body is 7 to 7.8. It lies in between. Okay. So, in our gut, we are providing the acidic medium. If we are not providing the acidic medium, so the food would not get digested. Okay. In our mouth, we are also providing acidic medium. Okay, let's discuss it further. Also, our blood also do have a pH 7.2. Okay, so if this pH get disturbed, our cycle or our health would start to get affected. Okay, then pH for crops. There are certain crops that do grow in soil of certain pH. Okay, so there are crops like tomato. Tomato usually grow in soil which have pH slightly on the acidic side, whereas there are other crops like barley, wheat. So they do not grow in acidic soil. So the pH is also crucial for the crops to grow. Other than that, there are also microorganisms that do not grow or do grow in particular pH. Right? There are some microorganisms that can survive acidic mediums, whereas usually the pH should be normal so that the microorganism can grow. Otherwise, there would be no microorganism. No microorganism means no nitrogen cycle, right? The nutrients would not get cycled easily, and hence the soil would not be able to grow crops because there would be no decomposition or there would be no nutrient cycling. So the nutrient pool of the soil would start to get degrade or decrease, and hence the nutrients would be finished from the soil. And how would the crop be get nourished? From nowhere. So the pH plays a very crucial role in soils and in the sustaining of microorganisms as well as the productivity of crops, agricultural productivity basically. Okay. Then again, acid rain and aquatic life. So if there is rain, if rain is having pH 4, okay, so I already mentioned that if the pH of the soil, if the pH of rainwater is less than 5.6, the rain would be regarded as acid rain, right? Okay, so suppose the pH of the soil, sorry, of the rain is 4, and it is, so this is raining. These are the clouds which are raining. Okay, so this is a river which is flowing over which there are clouds and rain. pH of the rain is 4. So it would get mixed into this particular water. And the organisms, the fishes that were surviving in this particular water are not ready to bear very acidic medium, right? Because we already know the natural waters do have pH equal to 7 or neutral. So when this would get mixed, the pH of that particular water body would start to get fluctuate, right? If that is fluctuating, then what would happen to the aquatic life? It would start to get destroy or damage or finish. It would be finished easily. So it is required to maintain the pH of our, how is acid rain formed? So let me tell you. So we are releasing through air pollution or different activities, we are releasing NO2 and SO2, oxides of nitrogen, N2O, and oxides of nitrogen into the air because of vehicular pollution, thermal pollution, pollution due to thermal power plants, and all these activities. So when these pollutants reach the upper atmosphere, so in the upper atmosphere, water vapor, so these pollutants would react with water and form acid HNO3, okay, or H2SO4. And now we are getting the rain, which is acidic because of the formation of these two acids, H2SO4, sulfuric acid, and HNO3, nitric acid. So the rain is because of these two acids. Okay, acid rain is because of these two acids. So if we would uh, implement laws, follow rules and regulations, and do not emit much pollutants into the air, so acid rain would not be a problem. Acid rain होगी ही नहीं क्योंकि it is because of our activities. Okay, so acid rain also affects aquatic life. Then again, self-defense from insects like bees. Okay, as I already mentioned, when ant bites us or some other insects, so in their sting there is methanoic acid. So we know that कि हमें एक आंट ने एक बी ने काट लिया है. Okay, now we know this particular thing. Okay, so what would we do? We would uh, immediately apply a base. Okay, because we know that there has been a what acid which is injected into our body. So what would we do? To neutralize that particular reaction, we would add a base. बेस की फॉर्म में हम क्या ऐड करेंगे? बेकिंग सोडा. ओके, बेकिंग सोडा. Okay, we would add baking soda. Suddenly, we would rub it so that baking soda would neutralize the pH or neutralize the acidic properties. Right? We also rub few metals. Okay, so that the salt is formed and it won't hurt much. Okay, then again, tooth decay. So we already know that the pH, if the pH of teeth or enamel is the outer lining, if the pH drops less than 5.5, then our enamel would be damaged. So how can we protect our enamel from getting damaged? So what we can do is when we eat food, okay, so the food is neutralized and mixed with mucus and different activities are taking place for the digestion that we already have discussed in the chapter life processes. So these reactions are taking place which are resulting in the release of acids. Okay, so what happens if we do not brush our teeth after having our meals? So the acid that is formed in our mouth would start to decay our tooth and result in cavities and different problems associated with tooth. Okay, so this also plays an important role in tooth decay, right? Okay, let's get move ahead. Then next topic is salts. So our chapter was about acids, bases, and salts. So we are done with acids, reactions of acids, bases, reactions of acids and bases, and pH, their indicators, different indicators, etc. Now the term arises salts. So we are already familiar that how are salts formed. The salts are formed because of neutralization reactions between a acid and a base. So when a acid reacts with a base, a salt is formed. Okay, and the particular reaction is regarded as neutralization reaction. For example, NaCl is a salt, sodium chloride. Na2SO4 is also a salt. PaCO3 is also a salt. So NaCl is regarded as common salt. Okay. So common salt is used in food, raw materials for many chemicals that I'll describe in the form of with the help of a figure further that how it is used as a raw material for the formation of different chemicals. Okay. If a strong salt of a strong acid and a strong base are neutral with pH value of 7. Okay. So if a strong acid is reacting with the strong base, so the pH would be neutral. Okay. Okay. So if the salts of a strong acid and strong base are reacting, so the resulting compound would have neutral pH. Okay. स्ट्रॉन्ग एसिड स्ट्रॉन्ग बेस मिक्स हो गए पीएच 7 पे आ गया ओके बट if a weak acid is reacting with a strong base then what would happen basic solution would be formed and usually strong base similar to this if a strong acid is reacting with a weak base then what would happen then again acidic solution would be formed. And what if a weak acid and weak base would react? Then again a neutral solution would be formed. Okay, right? Okay. So now here are a few important chemicals that are from salts or okay, we are going to study about different salts. Okay. So first is sodium hydroxide. So how is sodium hydroxide formed? Through brine. Brine is what? Suppose we are adding NaCl in H2O. So the particular solution would be regarded as brine. Solution of water mixed with common salt or NaCl would be regarded as brine. So sodium hydroxide is formed because of brine. So now NaOH plus HCl would be formed, right? Right. Okay. Then there is another reaction or another salt that we usually called as baking soda or antacids. These are regarded as baking soda is the common name for sodium hydrogen carbonate NaHCO3. NaHCO3 baking soda, sodium hydrogen chloride. Baking soda is used for cooking purposes, baking cakes, fermentation purposes. So it is also a salt which is formed because of because of the particular reaction that we discussed previously. Okay, so there was reactions of carbonates as well. Okay, so if we are reacting a salt with carbon dioxide and water, then particular NaCO3 or Na2CO3, sodium metal carbonate, or yeah, metal carbonate basically is formed. Okay, then another salt or another chemical formed from salt is sodium carbonate, Na2CO3 dot 10H2O. Okay, sodium carbonate is used in detergents. It is also regarded as washing soda. Okay, so baking soda is sodium hydrogen carbonate, NaHCO3, and detergents are washing soda, Na2CO3, which is called as sodium carbonate. Okay, then again there is CaOCl, which is regarded as bleaching powder. Bleaching powder is used for disinfection of particular water or another solutions, or bleaching powder is also used in washing clothes, dyes, and other purposes. So bleaching powder is CaOCl, and it is also regarded as calcium hypochlorite. So the chemical name for bleaching powder is calcium hypochlorite. Do not forget these chemical names and their formulas or their common names, because they are really very important from the exam point of view. Because if you would not know that what bleaching powder or detergent or baking soda stands for, then how would you get to know that a particular question is demanding what? Okay, so if they are saying that the baking soda is reacting with this particular thing, then how would you get to know that baking soda is what? So please make sure to remember and recall these things time to time so that you don't get confused in the exams. Then there is a process, very important process, which is regarded as chlor-alkali process. So, as I previously mentioned, that common salt is used as raw material for many chemicals, right? So this is how it is used for as a raw material for the formation of many chemicals. So there is brine. Okay, brine is what? H2O, H2O plus NaCl. So common salt mixed with H2O is regarded as brine. Okay, so we have taken brine in a particular container, and we have added two rods. One is positively charged and other is negatively charged. So anode is negatively charged, whereas anode is positively charged, whereas cathode is negatively charged, right? So on the positively charged anode, there the negatively charged ion would start to get collect, right? Chlorine is negatively charged, so it would accumulate or evolve on the anode side, whereas mm, sodium, which is positively charged, would get deposited or would release from the cathode side, which is negatively charged. So we know that the opposites attract. Okay, so the positively charged ions would be attracted to the negatively charged rod, and the negatively charged ions would be attracted to the positively charged rod. Okay, so anode is positively charged, it would attract negatively charged ions, which is chlorine. So chlorine would evolve from the anode side, whereas sodium would get deposited on the cathode side. Or also the hydrogen is evolved. Hydrogen gas is also evolved from the cathode side. Okay, so hydrogen and chlorine, these two things are getting evolved in this particular reaction, chlor-alkali process. And Na is getting deposited on the cathode side and further reacting with the hydrogen and resulting in the formation of NaOH. So this alkali NaOH, and NaOH is what? Alkaline in nature, because it can dissociate into OH minus ions, right? It can be dissociated into its ionic form. It is soluble in water, so it is regarded as alkali. Otherwise, it would we have considered as only base. So NaOH is alkali. Okay, and the formation of alkali is formed. Alkali is taking place, so this particular process is regarded as alkali. Chlor, because of the evolution of chlorine gas at this particular point. So the particular process of the formation or the evolution of chlorine gas and formation of NaOH from NaCl, इस प्रोसेस को हम बोलेंगे क्लोर एल्कली प्रोसेस. क्लोर stands for chlorine, alkali stands for NaOH, and the process is taking place. The formation of chlor-alkali process takes place in this manner. Furthermore, the NaOH which is formed is used in degreasing of metals, formation or manufacturing of soaps and detergents, making of paper and artificial fibers. So this is how NaCl or common salt is used as raw material for different chemicals. Again, hydrogen, which is evolved over here, is used in fuels. Hydrogen can be used as a fuel. Margarine, ammonia for fertilizers. Okay, Haber's process से हम ammonia बनाते हैं. That you would study in further classes. Okay, Haber's process. Then again, chlorine, which is evolving on the anode side, is used for the treatment of water so that it would appear crystal clear, right? In swimming pools, it is added so as to neutralize all the wastes. PVC pipes, disinfectants, CFCs, chlorofluorocarbons में chlorine हम use करें, and in pesticides. Okay, so these three things which are evolving or forming in this particular reaction, chlor-alkali process. Okay, so this process is taking place because of the NaCl, which was used as a raw material, and this is further getting used into different forms. Okay, so remember this that common salt or NaCl is used as a raw material for the formation of different chemicals, right? With the help of chlor-alkali process. Do not forget about this chlor-alkali process. NaCl plus H2O gives NaOH plus Cl2 plus H2. Okay. So, yes, and here comes our next topic, that is plaster of Paris. Plaster of Paris, you might have heard that the plasters, when your bone gets fractured, doctor gives you a plaster. That is because of, that is what? That is calcium sulfate hemihydrate. Calcium sulfate hemihydrate is commonly called as plaster of Paris. So it is used in the making of toys, materials for decoration, and making surfaces smooth. So when we heat gypsum, okay, gypsum is CaSO4. CaSO4 को जब हम heat करेंगे, CaSO4.2H2O. So it basically contains CaSO4 basically if it contains two water molecules, so it would be regarded as gypsum. But when we heat gypsum at 373 Kelvin or 100 degrees Celsius, so the water would get evaporated and the gypsum would get dehydrated and it would be regarded as calcium sulfate hemihydrate. So it now do not contain water molecule and the formula is half H2O. Okay, so the difference between this and this is the absence of two water molecules, right? Okay, so the plaster of Paris can be converted into gypsum by addition of water, whereas gypsum can be converted into plaster of Paris by heating at 100 degrees Celsius. This is so simple reaction, right? So that was it about this particular chapter. I hope you get to know much. If you have any doubt, you can write down in the comment section. I can read them later and answer accordingly in our coming videos. So till then, keep on revising the terms and don't forget to practice NCRT questions and NCRT questions. If you have any doubt, you can come to me anytime. That was it about this particular class. Thank you very much. Take care. Do study well. Thank you. Bye bye. Good night.